Hello everyone. Welcome back to our channel. Today we are diving into an exciting project using Xilinx Vivado where we'll be simulating a lab experiment for the design of 4-bit binary to gray converter. This experiment is part of the CMOS VLSI Design Laboratory for BTEC, 3rd year, 2nd semester. Following the JNTUH curriculum for ECE students, we'll walk you through each step of creating a Vivado project for this specific lab experiment. Don't forget to hit the like button, subscribe to our channel and ring that notification bell so you never miss out on our educational content. So let's get started. To simplify the Xilinx Vivado project creating process, we shall create our source Verilog files and Testbench beforehand. In a Windows machine, open Notepad. Write the Verilog logic in the file. While saving, select Save as Open. Choose the location where you want to save your Verilog file. Give suitable name to your Verilog file and give extension .v. Then in Save as Type option, select all files in braces .option. Click Save. Repeat this procedure for all the Verilog sources and Testbench files. After creating all the files, we shall proceed to project creation in Vivado. Open Xilinx Vivado by clicking on its icon from your desktop or Start menu. Once Vivado is open, click on Create Project to start a new project setup wizard. Press Next on the introductory dialog box. Assign a name to your project such as B2G, _converter and specify the location where the project will be stored. Click Next to proceed. Ensure RTL project is selected. Confirm that Do Not Specify Sources at this time is not checked since we already have the Verilog source code and the Testbench files. Click Next. In Add Source window, select Add Files. A new window will open to allow selecting the files. Go to the corresponding folder of RTL codes and Testbench codes to add the files. After adding all the files, specify that Testbench is to be used during simulation only and click Next. As we are not adding any constraint files, just click Next in the next window for adding constraint files. In the default part screen, select the FPGA board or part you will be targeting for this project. You can use the filters or search function to easily find your device. Click Next after making your selection, then finish to create your new project. After successfully creating the project, navigate to Flow Navigator, Run Simulation, Run Behavioral Simulation. This will compile all your Verilog files and run the simulation based on your Testbench. After the simulation runs, use the waveform viewer to inspect the results. Verify that the outputs match expected results based on the input scenarios defined in your Testbench. You may be required to restart the simulation to see the waveform within the required time frame. After restart, set the simulation time and click Simulation icon. Click Zoom icon to see the complete waveform. In the Flow Navigator on the left side, under Project Manager, click on Run Synthesis. Vivado will process your design files to synthesize the circuit. This may take a few minutes. In the Xilinx synthesis process, your design code is transformed into a gate-level schematic, optimizing for performance and resource utilization. First, the process reads and interprets your HDL hardware description language files, analyzing the design's structure and functionality. Next, it optimizes the design by reducing complexity and improving speed, ensuring it fits within the target FPGA architecture. Finally, the synthesized design is mapped to the specific logic elements of the FPGA, ready for further simulation and eventual implementation on the hardware itself. Upon completion, a dialog box will appear. Ensure to check Run Implementation and click OK. The implementation process starts automatically after synthesis if you selected the option in the previous step. This step converts the synthesized design into a device-specific layout. Wait for the implementation to complete. This might take a while depending on the complexity of your design. In the implementation phase, following synthesis in the Xilinx toolchain, the design undergoes placement and routing where synthesized components are assigned specific locations on the FPGA and interconnected. This phase is crucial for meeting timing constraints and optimizing resource allocation. Various reports are generated throughout, including the utilization report, which details how much of the FPGA resources are used. The timing report assesses whether the design meets its specified speed requirements, and the power report estimating the design's energy consumption. These reports provide invaluable insights for designers to refine and enhance their FPGA-based projects, ensuring optimal performance and efficiency. When the implementation finishes, we will see a window to see the reports. Click on Open Implemented Design. Navigate to Flow Manager. Under Open Implemented Design option, click on Report Utilization to check the utilization of top module in the design. After implementation, navigate to the Flow Navigator under Project Manager and check the options under Open Implemented Design. Select Schematic. This opens the schematic viewer. Go to Project Summary tab to see the resource utilization details and power consumption. Review the simulation results, synthesized schematic, and implementation details to ensure your design meets the desired specifications and performance criteria. Make any necessary adjustments to your design based on this analysis. Save your design and project after every modification cycle. Exit when you are finished with your session. And that wraps up our tutorial on simulating a lab experiment for the design of binary to gray converter using Xilinx Vivado. We hope you found this guide informative and easy to follow. With these steps, you are well on your way to mastering VLSI design and simulation using one of the most powerful tools in the industry. For more details, source code, and the lab manual related to this experiment, make sure to visit our webpage at research1.fun mentioned in the description. There you'll find a treasure trove of resources to further your understanding and skills in VLSI design and many other areas of electronics and communication engineering. If you enjoyed this video and learned something new, please consider giving us a thumbs up and sharing it with friends or classmates who might also find it useful. Your support means the world to us and helps us create more content like this. Got questions or suggestions for future videos? Drop them in the comments section below. We love hearing from you, and don't forget to subscribe and hit the bell icon so you never miss out on our upcoming tutorials and guides. Thank you for watching, and we'll see you in the next video. Happy designing!